Hello aspirants, welcome to our channel Physics World. Hi, how are you all? I hope you are all doing good at home and I am also good. Before going to the topic, please do subscribe to our channel and click on the bell icon to get the latest updates of my videos. Okay, in the last class we have discussed about the refractive index, no? Yes, and then on what factors this refractive index will depend upon. See, as the refractive index is nothing but the speed of the light in vacuum to the speed of the light in that particular medium. Okay, so to know in deep, if you know on what factors this will depend upon. See, on observing carefully, the refractive index depends upon the nature of the material and also wavelength of the light that we are using. Okay, and this nature of the material, it is as simple as it is to understand, but of course in depth if you go means you will get this optical density also. Okay, first let us see the material it will be a solid, it will be a liquid, or it is a gas. Yes, how like the molecules in that particular matter arranged. See here in the solid how the molecules are arranged. They are tightly packed, and in the liquid somewhat loosely bound, and in the gas how like they are freely moving. Yes, you have observed all these things, and observing all these things definitely you came to a conclusion that suppose if I am pouring water, or else if I am allowing something to pass through it, what will happen? It will freely pass through gas. Yes, of course. Why? There is a more free space is there, because the molecules are loosely bound to the nucleus. In this, if you are allowing something to pass through it, then you will get easily through that material. But in case of solid, if you are allowing to pass through anything means, will it go that much freely compared to gas? Yes, of course, it is not. That itself we are giving one major term, that is nothing but optical density. What is the optical density? See, you are observing here the degree to which a refractive medium retards transmitted rays of light. Retards means what? Just it is making to stop, right? It is stopping. Why it is stopping? Because of the molecules that are how like the pattern of the molecules, whether they are tightly arranged or else loosely. It like that it is allowing the light to pass through it. While passing through it, if it is free like gas case, it will allow, it won't retard that much. It will retard definitely. In all the three cases, the retardation is guaranteed. But how much? How much is the retardation? That we can get to know through the molecules, right? And this we are going to discuss the two major mediums. What is the first one? The first one is optically rarer medium, and the second one is optically denser medium. The optically rarer medium is that in which the speed of the light is faster. As we have discussed, rarer means speed will be faster. So if the speed of the light is fast means how like the molecules may be, it's just assumption only. Listen carefully. See, the molecules are loosely arranged so that it is allowing the light to go fast. Okay. Then what will be the optically denser medium? Yes, of course, the medium in which the speed of the light is slower. That means the molecules arrangement will be dense. Dense means it is high in number or else packed together in that material. Okay, so for that reason only it is restricting and retarding greatly. So if it is retarding that light means after traveling through that material, what will happen to the speed? Definitely it will get slower. So we got optically rarer medium and optically denser medium. So how like we can conclude in case of the examples like in case of refractive index, we have discussed air is one of the medium, glass is another medium, and water, whatever it may be. See here, we have given one table itself, no? The refractive indices of some materials. These are all will be acting as a material, no? Yes. If they are acting as the materials means how like we need to get that optical density of that particular material? Yes, we will get that optical density just by taking refractive index. See, what is the refractive index formula? It is nothing but whatever the speed in vacuum to that of the speed in that material. Actually, we know the speed of the light in vacuum is a constant value 3 into 10 power 8 meters per second that we have already saw now. See here, the speed of the light in vacuum is nothing but 3 into 10 power 8 meters per second. That is constant value. So we need not to take that as a variable term. As we know, variable is nothing but it will change when you are going to change that quantity. But it is a constant, it will not change. So on what factors this refractive index will depend upon? Definitely the velocity of the, speed of the light in that particular medium. So, as the speed of the light is in the right hand side in the denominator. So, how like we need to take inverse relation for the medium, refractive index of the medium is having the inverse relation with the speed of the light in that particular medium. So, definitely we can say that refractive index of the material is inversely proportional to speed of the light in that particular medium. So, if the speed of the light is slow, then how like the refractive index will be more. If the refractive index is less, what will happen to the speed of the light? It will increase. Okay, inverse relation means if you are increasing or decreasing any one term, the other term will definitely decrease or increase. Okay, and see, glass, what is the refractive index of the glass? That we need to take, 1.5. And what is the refractive index of water? 1.33. What is the refractive index of air? 1. See, in this, which material, which medium having the small refractive index? Yes, air. If the refractive index is less means what will happen to the speed of the light? As refractive index is inversely proportional to speed, so what will happen? Definitely the refractive index of the air is low, the speed of the light in that particular air will be faster. Then how like we can decide the optical density? Definitely the speed of the light in the particular medium is slow or faster. What we have decided because of the refractive index of the air is 1 and the velocity of the light or speed of the light in air, how like it will be? More. So if the speed of the light is more means, can we take that as an optically rarer medium? Yes. So according to, based on that one, we can decide what will be the optical density. See, for glass, the optical density will be more, and that means glass is a optically denser medium in which speed of the light will be slower, and next the optical density of the water will be lower than the glass and higher than the air, and optical density of air is much lower than glass and water. So how like the velocity, just we have discussed now, as the refractive index of air is 1, water is 1.33, glass is 1.5. So the velocities will be in the reverse order. Air, the speed of the light will be higher, and then water, and then glass. So in this way we need to discuss and we need to define what is the optically rarer medium and optically denser medium. And next thing, what is the refractive index on which it will depend upon? The second thing that we have discussed, wavelength of the light used. What is the wavelength that we have used? That one we need to know first what is the wavelength. See here, the wave, whatever the color of the light it may be, between any two crusts or between two any troughs, the distance that we will call it as the wavelength. What is the velocity expression for us? As we are reading from previous classes onwards, it is nothing but frequency upon wavelength that will give you velocity of the light wave. So this velocity is inversely proportional to wavelength or not? Yes. If the wavelength is more, the velocity will be less. If the velocity is more, the wavelength will be very less. So I think we have the visible spectrum as a VIBGR. As we all know, as a science student, we all know what is a VIBGR. It is nothing but violet, blue, green, yellow, orange, red. These are the VIBGR colors that we can simply say it is a whatever the colors that we can observe. So what is the wavelength and what is the frequency of these colors? Yes, the red is having, red color is having the greatest wavelength of all the colors, visible colors to be said for us. So we are going to consider from violet onwards. Violet will have less wavelength and red will have greater wavelength, and the frequency, red will have less frequency and the violet will have more frequency. See, on observing this one, can we give one statement? As the wavelength is inversely proportional to speed of the light, yes, V is equals to frequency upon wavelength, no? So, if the frequency, if you are considering it as a constant, means it will be inversely proportional to velocity of the light that we are using. So, as the inverse relation is there, how like the wavelength will be? Yes, of course, the wavelength of red is greater than compared to all colors. The decreasing order of the wavelength of the colors that we have given, and we are deciding what will be the velocity of the colors. See, the velocity of the light in red color is less compared to velocity of the light in violet color. So this like we need to decide. So if you have given red color light, how like the velocity of the light will be? See, if you are passing the light into the, red color means how like the velocity will be lower compared to violet. Okay, ma? So these are the two factors that will depend upon. So hope you all understood. Thank you. Take care.